here we are in 9.6. We're at the top of page 1 of the notes. We're still in the chapter on roots and radicals. This section is titled Rational Exponents. And as you recall from Math 60, learning about what rational numbers are, rationals are anything that can be put in fraction form. So what that means is we're going to be dealing with exponents that are fractions. They have both a numerator and a denominator. Okay, so let's recall here, square root of x cubed can be simplified. Remember when we were doing this early on in chapter 9, we said, okay, one way to do that is to take your exponent and divide by your index. Where this 3 here is your exponent. The number here inside that little nook of the radical is your index. In this case, when it's empty, it's equal to the number 2. It's a square root. So we can simplify that by taking the exponent divided by the index. In this case, we had 3 divided by 2. And we said, okay, that means that when you have 3 divided by 2, it goes in once. So you're able to bring one of these out, x to the first, and there'd be a remainder of 1. So one exponent would stay inside. So this would simplify to x to the first on the outside, x to the first on the inside, outside, inside, and that would just be x radical x. Now, what we want to focus on though is not the simplification, but what a different way that we could write this instead of doing the radical x cubed, because 3 divided by 2, a division is division, and a division is the same as a fraction. You can express division using a fraction. We can say 3 divided by 2. We can write that as 3 over 2, and it means the same thing. So that means another way to denote roots is you could take radical x cubed, and we can write that as x to the 3 over 2. 3 halves would be the exponent, where the 3 is the power, what you saw inside the radical, and 2 is the index. The denominator of the power, the fractional part, would represent the root, or the index, however you want to describe that. Okay. So we're going to get some practice first in simplifying, being able to write the expression in radical form. So taking the fractional exponent and being able to put it back into radical form, which is what we're kind of familiar with at this point. Okay, so we're just going to get some practice going back and forth. And if you need to, you can use a calculator to verify your answer to make sure that you set it up okay. So let's start here with number 8. You've got negative 27 raised to the 1/3. Again, let's just review what we're just introducing here. If it were negative 27 to the first, it wouldn't change anything because everything to the first power is just the same. So the 1 is the power, the numerator is the power, the denominator is the root, or the index of the radical that you're going to be using. The other thing we want to note here before we jump into this one is, remember, unless there's a parentheses, that negative out front is really negative 1 times 27 to the 1/3. The 1/3 does not apply to the negative 1 here. It would require parentheses for that exponent to apply to the negative. So it's just plain old negative 1. And then we've got 27 raised to the 1/3, and we're just going to rewrite that as negative 1 cube root of 27, because the third is the root, so we'll just write that as a third. We're just rewriting it right now. And then we can go ahead and simplify. We know the cube root of 27, that's going to be 3, so it's still negative 1 times cube root of 27 is 3, and then our final answer is going to be negative 3. And let's do number 16. 64 over 125 raised to the 1/3. What's different about this one? Well, there's no negative, okay, so we don't have to worry about pulling out that negative 1 times what we see right now. But we have a fraction now raised to a fraction. Well, that's fine. Any number can be raised to an exponent. It may look a little different, may even look a little intimidating, but it doesn't change the fact that what we're learning right now is that the exponent is on the top, the numerator of the fraction is the power, and the denominator, the bottom of the fraction, in this case 3, is the root, or the index of the radical. So we're going to start by rewriting this as a radical. So that's what we're doing, simplifying by first rewriting the expression in radical form. So it has a power of 1, a root of 3, so this becomes cube root of everything we see here, 64 over 125. So a big old cube root there. Now we can use what we know about simplifying. Well, in this case, we know that simplification can be broken up because division, radicals, roots, multiplication, it's all in the family. So we can split these up into 2 cube roots. Cube root of the top, 64, and cube root of the bottom, 125. What does that get us? Well, we know that the cube root of 64 is 4. Cube root of 125 is 5. For those of you that kind of stumps you, you need to go back earlier in chapter 9, and there's a little study tip box on one of the pages that will help you get familiar with these cubes and the fourth roots and fifth roots, some of the more common ones. You want to be able to recognize these. That means you need to memorize it to be able to recognize it. Do it. This will save you tons of time and energy on the test, literally. Some of you are noticing that you make mistakes towards the end of the test because you're tired or you're rushing. So if you can save yourself some time and energy by recognizing this and not even have to put any effort for it, you just know it's 4, you know cube root of 125 is 5, think how much you've helped yourself, time, energy, and less mistakes in the end. Okay, so here's one to try, number 10. First of all, make sure that you've talked this through with somebody and that you understand what's happening here. And again, these are just 2 examples that I've pulled out. You'll get to try lots more as you go through. But here's one to start with, 81 to the 1/4. And pause the video now and try it, and then come back, see how you did. Okay, so it says to first write the expression in radical form. If you do that, that should be the 4th root of 81, and that's one of the ones you want to be able to recognize, and that does give you an answer of +3. Okay? And then we'll try some more examples down at the bottom of this page in the next video.